Even on 2 more people. Here they are. All right, so 2.2 very much related to 1.1. Identify the effect on the graph of a function of 2 or more transformations by adding a number to the x or the y value. So we're going to look at the graphs that you looked at yesterday on the handout. We're going to do even more transformations. So still really using this vocabulary here and adding to it. So I'm going to give someone actually an opportunity to volunteer for some extra credit and come to the board and do number 2 here. If you volunteer, you can bring somebody with you. You guys can talk about it, and even if you get it wrong, you still get extra credit for coming to the board. So, are there any volunteers to come to the board, draw a parent function, and translate it 5 units down? Yep, go ahead. I'll take probably one more volunteer after. Pick any of the parent functions on the front of the handout, translate it down 5 units. Put your phone on. Hey, okay. Which function family did he choose? Colin, right? Which function family did Colin choose? Linear. He chose the linear function family. And it is down 5 units. You actually did 2 transformations here, though. Oh, yeah. You flipped it. Yeah, that's cool, though. So this one is y equals negative x because it has a negative slope. And this one is y equals negative x minus 5. And that's exactly why it's great to have students come up, because we can observe different things like that. Very good job. So let's do another one. I need a volunteer to do not linear, some other function family here. And I am definitely not looking for perfection, just something to look at. We have an absolute value function translated down 5. And I got something to point out here. This is great. Got the V shape down 5 units. Boop. Went the extra mile, wrote the function. This is what I'm going to do here. The original we're going to call f of x. Now to show that we've changed f of x and made it something new, I'm going to erase the f. And I'm going to call the new one g of x. Okay, slight little detail that you will see in directions. It'll say, given the function f of x, create h of x, which is right 4. Okay, so we'll call one f and we'll call the new one any other letter, whatever it says normally. Okay, that's good. That's good for me. Very good job, you guys. Let's move on to the handout. I'm going to go over some answers. I did number 2 yesterday. right, number one, your skill yesterday. If you were here yesterday, what you should be mastering at this point is naming the function family. This is a V shape. Everybody should say that this is absolute value. Did anybody who just came in was not here yesterday need to hand up? Okay. Now I'm gonna put that parent function there. This is the original. How is this one different? Anybody in the room want to give one reason it's different? Yes. Left 2 units. Okay, the left 2 I see right here, which is weird because it says +2. But the number in the brackets with the X is responsible for a shift left and right. So I'm giving you guys some information here. If it's with X and it's in parentheses or brackets, that's going to shift a graph left or right. What's another thing we see here?
Vertical translation of negative.
Good. We're using our nice vocab. Vertical translation of -8, and I see that here. A number at the very end, not in parentheses or brackets, will shift a graph up or down. What's the last one? There's one more. How is it different from the parent function? Leah? Slope of 2. I like how you called it a slope. It does. So we're going to call that a vertical stretch up 2, and Leah's absolutely right. We can see it as a slope. The original, when we did the table on the front, has a slope of up 1 over 1, up 1 over 1. This one, if you look, is going up 2 over 1, up 2 over 1. It's got a steeper slope. A steeper slope is called a vertical stretch. So this value in the front, this 2 is what's causing that slope to change. This value indicates a vertical stretch or shrink. Okay? So I'm going to pause for a minute and show you some notes. You don't have to write it all right now. I'll give you time in a minute. These are your notes for today. This is the information about absolute value. This is the parent absolute value function. And this is how we identify different transformations in that function. The number in front we call A universally. The number in the brackets we call H universally. And the number at the end we call K. It looks the same for all the function families. All of them in the whole slew of function families, not just the 4 we have. If there's a number in front, we identify it as A. If there's a number in parentheses or brackets, we identify it as H. And if there's a number at the end, we identify it as K. And they all affect the graphs the same. Okay? The A value in the front, if it's negative, will create a reflection. If it's more than 1, it'll cause a stretch. And if it's less than 1, it'll cause a shrink. Okay, so in this example, the A value was a 2. We had a stretch. The number in the bracket we call H, and that's a horizontal translation, and it's opposite of what it looks like. And that's due to the subtraction sign there. So if I was just to look at this, my very reasonable mind would think that it would go right because it's positive, but it actually shifts left. Because the H value does opposite of what it looks like. And then the K value at the end will shift something up and down. So. We did 2 yesterday. Let's look at 3. And I think it was your class that identified that 3 is meant to trick you. The curriculum will do this kind of a lot throughout the year. The X's are going by 1s, and the Y's are going by 5s. So they've completely thrown off their proportions, just to get you tuned into details. Linear family. What's one change we see here? Someone who hasn't gone yet. I guess this is the hardest one though. Anybody yet? See a change? Yes? Yeah, vertical translation, -2. It doesn't look like it's down 2. It looks like it's down like a third. But this is actually -5. This is going 5, 10, 15, 20. So this was kind of difficult proportionally. This is -5 here, so this is just above halfway, -2. And I can see the -2. That is a K value, down 2. All right, what's the other one that maybe you didn't get yesterday, but you're starting to see it today? It's a stretch. It's a vertical stretch of 5. There's a 5 here. It's called an A value. It's so hard to see a slope of 5 here. It's like, here's a point and here's a point, right? And this is 5 and this is 2. So this is probably the ordered pair 1, 3. Am I right? It is, yeah. That's 5, 1, 3. That's it. Just 2 transformations that time. Last, the constant. Constant never has anything really fun going on with it. I will do the parent function here. Here's the parent function at y equals 1. So you may have accidentally set up 3, since it's at 3. Go ahead and correct it, say it's up 2. And that's because the parent is at 1, not at 0. So starting from 1, it's only up 2 units. It's not up 3 units. That one doesn't go through the origin. And then the word problems look so intimidating, but you just had to say what function family they are. And this one is quadratic because it's squared, and this one's linear. Depreciation and throwing something in the air. Okay. Any questions? I'm gonna walk around right now and give you credit for doing this work, so keep it out. While I walk around, you guys should take these notes. On your bellwork, underneath your bellwork today. Feel free to shorthand. As long as it's in your heart, shorthand it. Write things down that are helpful to you, and then ask questions. Oh, at the end of class on the way out. Thanks for asking. This actually right here, I wrote it. Coming around, giving you credit for your work, 4 points. Very good. Assignment credit, I should say. Okay, as you're reading and writing, does anybody have a question about what they're seeing, what they're looking at? Make any sense? I'm gonna call on people and ask about this example here, and it's written in black marker. So, but I can wait. I don't need to rush you.
So horizontal will always be opposite.
Yeah.
Which is just weird, really, isn't it? It's opposite of what it looks like. And that's because there's a minus sign in there.
As we go through, we work with this model with A, H, and K in every chapter. So different characteristics and different functions come to pass. All right, let's start. When I look at this, when I look at this example here, what would we call the three, A, H, or K? This is an A value. This is a quadratic function. So I'm picturing a parabola already when I look at it. The negative sign means that the parabola, the arrows are going up in the parent function, but since there's a negative sign, I'm picturing the arrows going down. The A value is 3. This says for A values that are greater than 1, there's a vertical stretch. So it's been stretched vertically. So I'm picturing a skinny parabola that's flipped over. All right, what's the 4? Would we call that A, H, or K? It's an H value. H value is a horizontal translation. Now, this looks like a -4 or a -4, but this is actually going to shift my parabola right 4 units. And then is the 8 an A, H, or K? It's a K value. So that's going to move it 4 units up. So without making a table, right now my brain is seeing this parabola. I'll do a quick sketch of what I see, right? First off, I know it's right 4 and up 8. So I'm going to go right 4, up 8, and there's the vertex. I know the middle is right 4 and up 8. I know the arrow should point down, and it's pretty narrow. So that's a quick sketch. That's what I can visualize already just by understanding what A, H, and K do. The original parent is here, and this one I can match up. It's going to look more like that. Okay. Now to get these points precise, I need a table, or I need to plug in for X, or actually, I could make these pretty precise right now. Normally, in the parent quadratic, from the vertex, it's only 1 unit away. But because there's a stretch of 3, it's going to be 3 units away. So it would be, since this is at 8, the next point would be at 7, 6, 5. Would be at 5. Okay. It takes a while to figure that part out, so don't worry. But if you can picture it flipped over, skinnier than usual, right 4 and up 8, that's the lesson of the day. Did anybody write the assignment down that you saw in the Bellwork slide? I'll point it out for you guys. Here's the Bellwork slide. When you come in every day, you should see your assignment always right here. Okay, so you know right where to find it every day. It's here and it's on the assignment wall. So you guys are working 7 to 13 on that handout. You should, on every one of these, have 2 lines graphed. The original parent and the transformation. Is there a question? Yeah. 12? Okay, wonderful. Alright, I'm going to jump to 12, everybody. If you want to start at 12 with me, feel free. Right away, you're going to see the benefit of having your own graph paper. This is right out of your textbook. This is what they give you to graph with, which isn't bad. I'm not complaining. It's better than nothing. The mistake people make at first is they draw the x-axis here and the y-axis here. Put it in the middle, okay? And over time, you'll start to predict the best place for it. But right now, you're probably just going to guess. Sometimes it's going to fit great. Sometimes it's not. Sometimes you're going to end up going way off where you wanted to be. You're going to end up graphing above it or below it. That's okay. If you have your own graph paper, you can make it as big as you want. Okay, so it's Isabella, right? Isabella picked 12 to ask you about. 12 is a bit of it's a bit confusing because it's not written the right way. Now, because you're just learning this, you might be thinking this 4 represents an A value. Because I told you A values come right in front. But A values are supposed to have multiplication between them and the bars. There's not supposed to be a plus sign. So this is actually a trick. This 4 here is actually a K value. They presented this not in standard form. So let's everybody rewrite this the way it should be. It's annoying that they try to trick you, but they do. So this should be written absolute value of x plus 4. Does that help? Okay, so let me go ahead and put the original down. It says graph the parent, so you want that original, and then if you know you have a graph right and you have a highlighter, you can highlight the original parent function. And then do the new one in pencil or something, or whatever you want. Alright, so I've told you that this +4 is actually a K. It was a sneaky little K hiding in the front, but it was a K value because it's attached by a plus sign. It's not in the brackets and it's not multiplication. So that means we're going to shift this guy up 4 units. So I'm counting 1, 2, 3, 4. And wouldn't you know it, I'm off my grid. I'd love for my work to be neat and perfect. It's not perfect, and that's okay. Don't stress out. Your graphs are going to be all over the place. You're going to have lines going through typing, and that's okay. There it is at 4. And I think the one above it has to move down, so they might get kind of messy. That's why I said if you really love neat graphs, get your own graph paper and spread it out. That's a full answer for 12. I said it was up 4 units, drew the original, drew the new one, done. Let's take another request. Who's got a question? Which one are you working on? What are you thinking? You got one? You got
So on number 11, there's the -5, the absolute value symbols. Will they go left or right?
goes right. might come natural to you, or might not. So one thing that helps is just to count every single point. So get the original on there. And then every point in the original, you can literally just count it, right 5, 1, 2, 3, 4, 5, dot. And then start the next point. 1, 2, 3, 4, 5, dot. 1, 2, 3, 4, 5, dot. Count it 5 units. Or if you really understand the image, you can just replicate it 5 units to the right. If you know the slopes of the lines and the branches, you can just draw it 5 units over. It's interesting. Our next section, the whole thing focuses just on this one. So we'll spend more time on it. We spent a lot of time on this. So the maximum linear. The maximum is no exponent. Reflection is pretty tough for a line here. On 13 is a linear. This is a linear function family. Negative sign in front is negative. Reflected. So here's the parent. I know from the front of the handout. Reflected just has a negative slope. It's a negative slope line. This is a positive slope line. And what we've been challenged with here, this g of x, is a negative slope line. So you can start at the origin and just go down one, right one, down one, right one, and that'll do your reflection. You should be making mistakes, doing it wrong, fixing it, correcting it. That's the process of learning. Shouldn't just look at this and immediately get it all right the first time. Don't put that pressure on yourself. It's the act of doing it that makes you learn it, not watching me do it. You doing it yourself.
What if a negative is inside the curve?
Like 14?
Yeah.
Something like that. That is, notice here I put reflection across X because it's the most common one or typically challenged to do. If it's in the parentheses, it's going to reflect across Y. And the best way to understand that is actually to make a table.
So when did you see the thing?
Yeah, that's cool. It comes out looking exactly the same.